Hello, this is Dr. Himangi Patil, and I am recording this video to help you with scientific method and scientific reasoning. So first we want to talk about scientific method, and scientific method is a linear path. So we are going to talk about each component of this path. It all starts with an observation. With an observation, human being a curious animal, we start asking questions. These questions are called scientific inquiries or scientific questions. Once we have question, we want to know the answer to that question, and therefore we start reasoning. When we reason, and there are two different ways of reasoning, and we will talk about that in a few minutes, we will come with the best tentative answer for our scientific inquiry. And that best guess or the best tentative answer is called hypothesis. Once we have hypothesis, we can design experiment to support our reasoning. We can conduct experiment. We can collect data, which is again observation of the experimental situation, and then we can analyze that collected data, and then we can conclude, look at the results and conclude, and then verify the results by repeating the experiment and formulate a theory. So this is a general flow of any scientific method. Remember, hypothesis is generated for one experiment. So each hypothesis will target one particular experiment, but theory is much broader than a hypothesis. So multiple experiments, multiple hypotheses can contribute to the generation of theory. Now let's talk about some individual components of this flowchart. First, reasoning. Reasoning is how you are thinking about the problem, and that can be done in two different ways: deductive reasoning and inductive reasoning. Deductive reasoning uses prior knowledge, while inductive reasoning uses experimentation. So let me give you an example. Say you received an email from an unknown sender. You do not recognize the name, and there is an attachment with the email. Your deductive reasoning will tell you, hey, don't open that email because unknown senders can send you computer viruses. Your inductive reasoning will tell you, hey, let's open that attachment and see if the unknown senders send computer viruses. So experimentation, do something and then conclude, that kind of reasoning is inductive reasoning. Deductive reasoning uses the previous knowledge. It may not be coming from your experimentation. It could be coming from literature, but any previous knowledge that you can use, if you use that to generate a hypothesis or to think about the question that you have generated, is called deductive reasoning. Now let's talk about hypothesis. Hypothesis is nothing but a statement. It's the best guess answer that you come up with for your scientific question. Now, there are some characteristics of a good hypothesis. A good hypothesis must be testable. That means you should be able to test it out, and it must be falsifiable. These are the two characteristics of the hypothesis. Now, hypothesis, usually in the scientific method, we will generate a hypothesis that you think is the best answer, and that hypothesis or that statement will be called as alternative hypothesis. This is what you reason why you reason the answer to your scientific question. Now, a negative statement of your hypothesis is called a null hypothesis. In science, we cannot prove anything, we can only disprove. Therefore, we need this null hypothesis, a negative statement of your reasoning. We need this so we can disprove null hypothesis and support our hypothesis. Now, let me give you an example of hypothesis. Say, right hand is faster than left hand. That's the hypothesis. That's my reasoning because I see more right-handed people. So I believe if your dominant hand is right hand, then the right hand will be having a faster response. It will be faster in catching a ball or catching a ruler or writing as compared to the left hand. So my alternative hypothesis is right hand has faster response time than left hand. My null hypothesis for this statement will be right hand does not, do you hear that word not, does not have faster response time than left hand. That will be my null hypothesis. So null hypothesis is always stated negative. The next item that we want to talk about is data. When we make observations are made of two different types. They can be numeric value, and when you make the numeric value observation, it's called quantitative data, and when you make a descriptive value observation, it's called qualitative data. For example, hair color of BSc 1010C class students will be a qualitative data because I'm writing down description of hair color. However, the exam 1 scores of BSc 1010C students will be a quantitative data because it will be a numeric value. Now, about the experimentation itself, there are some variables which have to be properly measured, properly controlled, and properly described in an experiment. We are going to talk about three of these. Independent variable. Independent variable is what do you change in the experiment. So if I'm looking at effect of light intensity on plant growth, I am changing light intensity. So light intensity is going to be my independent variable. In this case, I'm measuring plant growth. So what you measure, what data you collect, that becomes your dependent variable. And then we have some constants, also known as controlled variables. These are some of the variables that you want to keep constant throughout your study. So the kind of plant, the light source, all of these are going to be constant, something that you do not change. A good experiment will change only one parameter, one variable at a time to look for its effect. So now we are going to use this scientific method flowchart and some of its descriptions that we have talked about in case studies and graphs. Before we move on, let's see if you can recall what is a typical order of the scientific method. Let's answer this question. A testable explanation for an observation is called. Alright, so now that you have answered the two questions regarding scientific method or scientific flowchart, we are going to actually use this scientific method to answer questions in the case study. So this is your case study number 1. And what I want you to do is take a look at it, read through it so that we can discuss some of the variables and attributes that we have talked about scientific method earlier in this video. So I'm going to read it out loud for you. In 2010, an explosion on an oil rig caused a terrible oil spill in the Gulf of Mexico. As oil started washing up on shore, the area of wildlife was drastically affected. A scientist wondered, how do different amounts of water pollution affect the height of radish plants? He thinks that the plants with the most pollution will not grow as tall. He plants 10 seeds in dirt in separate cups and gives them water every day. He has mixed the water with different amount of motor oil as a pollution. He gives each tree a different level of pollution. He continues this for several weeks and measures the height of each plant. This is your case study. So first we are going to identify a problem. What do you think is the scientific question in this study? Take a moment, pause the video and answer the question. The problem or the scientific inquiry is how do different amounts of water pollution affect the height of radish plant? Now what's the hypothesis? The hypothesis is that the plant with most pollution will not grow as tall. So to answer the scientific question, when you reason and based on our deductive reasoning, we can say yes, pollution does affect plants, so they will not grow as tall or they will not grow as well with the pollution as compared to no pollution. That will be our hypothesis. What is the independent variable in this study? Remember, independent variable is something that you are changing. So different amount of water pollution will be the independent variable. What is a dependent variable? Dependent variable is something we are collecting data for, we are measuring. So we are measuring height of radish plants and that will be the dependent variable. What are the constants in this study? Well, there are 10 seeds in a separate cup and they are watered every day. That is a constant. That stays the same for every single plant. What is the measured data? The data is measured as a height of each plant. So now that we have gone through the first case study, I would like you to read out case study number 2 and answer the questions. Identify the dependent variable, independent variable, the constant, and then you will be answering these questions in the next slide. Now go ahead and read case study number 3 and identify independent variable, dependent variable and constants to answer the next questions. Now that we have studied how to identify variables in the case study, we want to take a look when we have result in form of say table or graph, and in table or graph we should be able to identify a research question, the conclusions that we can make and the variables for that particular study. So carefully evaluate the graph which is shown on the slide here and try to identify independent variable, dependent variable, try to identify the research question and some conclusions based on the graph. So the graph has x-axis which is right here and the y-axis which is right here. Now most often the y-axis will show you the dependent variable, something that you collect, something that you measure. So hospitalization per 100,000 people, the number of hospitalized people, that is a dependent variable in this study. The independent variable is usually present on the x-axis. So the year is the independent variable, and this 2000, 2001, 2002, these are the levels of the independent variable. The title of the graph usually will help you to identify a research question. When you look at this title, heat-related hospitalizations in 20 states from 2001 to 2010, you can formulate a research question. How did the hospitalization changed in 20 states during this duration, which is heat-related hospitalization? And then the graph can also help you, the data plot or the trend can help you with conclusions. For example, in 2006, there were most cases of hospitalization which were heat related. When you look for 2001 to 2010 data, there was the lowest number of cases were in 2004. Just based on this, one may also be able to hypothesize that maybe 2006 was a very, very hot year, and the temperature recorded temperature during this year perhaps was greater as compared to 2004, and that could be an hypothesis for another experiment. So take a look at this graph, identify the independent variable, the dependent variable, and some conclusions to answer the next questions. Next, we have a bar graph which talks about heat related hospitalizations in 20 states as per age group. Take a look at it so you can answer the questions in the next slide. This is a line graph. Again, there you need to identify the independent variable, the dependent variable, the research question, and some form of conclusion. This is a stacked bar graph. So we have a bar graph and there are multiple things which are tested for each of the independent variable level. So take a look at this graph carefully and then answer the questions in the next slide.